Hi guys, we're back, and before we move on to page 104, I don't think I did a good job of explaining standard form in the last video, so go back to page 103 and let me just run through the standard form thing again. It says write, oh, I can't move this someplace, gotta move it where you can see, write answers in descending powers of one variable. So in example A, there is only one variable. So we're picking variable x because it's the only one that's there. And so 2 was the highest power, then 1, then our constant. In example B, however, we had two variables. We had v and we had w. It doesn't really matter which variable you pick to write in descending powers. Generally speaking, you will see the one that comes first in the alphabet as the one that is chosen to write in descending powers. So I chose V, so we have V to the second power, V to the first power, and no V's at all in this back end. If you had chosen W instead, it would look differently, but it would be equally correct as long as you make sure you get that negative sign in front of the VW. All right, so now let's move on to the next page and talk through a couple more examples. We're going to add these two polynomials together. These are actually trinomials, a more specific definition for them because they have 3 terms. And we're basically just going to add them together. Do you need the parentheses? No, you really don't need the parentheses. So I'm going to rewrite it. And I'm going to look for like terms. And to remind you, to be a like term, the variable and the exponent need to be exactly alike. So I've got x squares. Let me do a different color here. I've got 5x squares here and 3x to the second powers here. So those are alike, and I can combine them. That makes 8x squares, and I'm just going to add the coefficients. Now let's move on. I've got negative 3x to the first power, y to the first power, and there's another x to the first power, y to the first power. I've got negative 3 of them and negative 2 of them. That makes negative 5x y. And then what do I have next? I have 2y to the second power here, 2 of them, and 1, ghostly 1 of them here. That's all positive. So I can add and say this is 3y to the second power. And this is in standard form if I choose the variable x, which I told you x comes first in the alphabet. So generally between x and y, you'll see the x as the standard form variable. So x to the second power, x to the first power, and no x at all. X to the 0 power, actually, right? We could say that, x to the 0 power, because anything to the 0 power is 1. All right, let's look at this second example. Again, I'm going to drop the parentheses, 3x squared minus xy plus 2y squared plus x squared plus 5y squared. You don't have to rewrite it without the parentheses. I just prefer not to look at them. Seems like it kind of crowds it to me. I've got x to the second power here, x to the second power here, 3 plus 1, the ghostly 1. If that helps you to write the 1, please do. That's 4 of them. Minus x to the first, y to the first, and I don't see any more of those, so that's all of him that I have. And then the y squares, again, I've got a positive 2y squared and a positive 5y squared. That makes 7y squared, and it is written in standard form if you are considering the variable x. So we're going to move on to subtraction. This is addition. We were adding polynomials. We're going to subtract polynomials now, and it's very, very similar, except you have to consider that this is a negative 1, and it needs to be distributed before you combine your like terms. So this guy distributes to each piece. I'm going to drop the parentheses on my first expression. I'm going to distribute negative 1, and I get minus 3x squared plus 2xy minus y squared. And now I'm ready to do exactly what I did in the examples up above. So I'm going to combine my like terms. I've got 5x squared here and negative 3x squared here. So that would be 5 minus 3 would be 2x squared. And I'm ready to move on to the xy terms. X to the first, y to the first, x to the first, y to the first. A negative 3 plus 2 is a negative 1, or just negative xy. All right, that takes care of him. And what's left are the y squared terms. I've got 2 of them here, and I'm taking one of them away. That leaves me with 1 y squared. So it is in standard form with regard to the x variable. X to the first, x to the second, x to the first, and x to the 0 hanging back here. Let's do this last one, and we will be done with this section. So distribute the minus 1. So I get minus 1, or just minus 4a, plus 2b, plus 1c, minus 1. So I've got 4 terms in this polynomial. It's easy to miss them. So be very careful that you have distributed to every single term. And I like to spread it out a little bit more. You can see I've kind of spread my terms out so I can identify the like ones a lot easier. So this is a to the first power. I'm going to go down the road here and see. There's some more a to the first powers, and that's all I see. So if I have negative 2 of them over here and negative 4 of them over here, that leaves me with negative 6 of them when I get them all together. And I'm ready to look at the next variable. So I have b to the first power, some more b to the first power. This is positive 3 and positive 2. That gives me 5 b to the first powers. Moving on to the next variable. I'll do a black, I guess. C to the first power, C to the first power, and it's negative 5 plus 1, which is negative 4c. And finally, I'm ready for the constants on the back end. This guy, positive 2, and a minus 1 is a plus 1. So we don't have any exponents except 1. This is a to the first, b to the first, c to the first. But I'm going to write my a first because it comes first in the alphabet. So this is the way I'm going to end this in standard form. Thanks for listening.